today's math lesson, you need to have out your math notebook, please, and highlighter, and your workbook you're going to be using today, not your textbook. Okay, today's lesson is one of kind of the hardest that we have in grade 6. So as I've been making this, I've kind of redone it from what I taught in the previous years, because I really wish that I could be there with you right now so we could work through this together. But I think you're going to get it okay. All right, let's just see how this goes. So, top of a new page, please write down expression with variables. Okay, so this is kind of like a mini introduction into algebra today. So this is, I don't think it'll be that bad. You guys will get the hang of it, I know it. But there might be moments where you're kind of thinking, what's going on? Okay, so this is the I can statement. I can represent generalizations arriving from number relationships using expressions with letter variables. What on earth is that? Okay, so you can represent generalizations, i.e. you can make up a pattern rule, okay? Arriving from number relationships. So that's like a table or a picture. We've already been exploring those, okay? So you can already do this part. This part is the new part, using expressions with letter variables, okay? That's what we're going to be focusing on today. So the work we did over the past week is this. Today we're just kind of adding on another little step. Okay, so first of all, what are variables in math? Now we hear about variables. You should have your, I'm sure you have little alarm bells going off in your brain right now because we use variables in science to represent something that is changing or something that stays the same. In math, a variable is a symbol or a letter that is used to hold the place of a number. So basically, it's like a placeholder. It's just kind of like sitting there, that would represent a number, okay? You'll get the hang of this as we do more. So basically, they represent the answer to what you want to figure out, but don't know the answer to yet. So it's holding the place, okay? So this would be kind of an example, okay? So what plus 2 equals 5? So this would be the what we don't know yet. We want to figure it out, right? So if I was to kind of like draw this, or if we were to write this down, let's see, okay? So that would be what would be like my question mark, okay? What plus 2 equals 5, right? That basically represents this, okay? So I know it seems kind of like maybe a little bit weird, but that's basically all that this is, okay? So this, in this place, this is my variable. My question mark is my placeholder. It's sitting there to represent something that I don't know. And this is a pretty easy one, right? Like we're gonna think, well, what plus 2 equals 5? Well, you can do this in your head. You know that the answer is 3. So that's what we're going to be doing today, is kind of figuring out how we can put in a variable to represent something that we don't know at this time. Okay, so a variable, this is kind of important stuff. A variable could be any symbol or letter. But there's a few kind of common ones. So these are common ones. So examples could be an X, but the thing is, if we're doing an X, it cannot just be like a classic cross. Okay, I actually should really show this to you. Rather than a classic cross, we do an X, so it's not this, okay? Because what does this look like? Multiplication, right? That would really mess up our brains. So if we're making an X as a variable, we want to draw it like this, okay? Maybe have you seen that before? Or, this is the way that I usually draw them, is like this, okay? So if you see this in math, it means a variable. It does not, or kind of maybe your mind's kind of thinking right now, oh yeah, like the X and the Y coordinate, right? It's not a multiplication symbol. Okay, so there you go. Make sure that you have that kind of drawn in. So, okay. So, or it could be a symbol. So it could be a question mark, it could be a happy face, could be a triangle, whatever. Okay, these are some common ones though. Do not use, if you're making up variables, do not use the capital I, because that could look a lot like the number 1, okay? Same thing, do not use as an O, because of course that could look like a 0, right? And then we already talked about this. We don't want to use X or we don't want to use T. If we are using T, it's fine. T is actually super popular, but you need to put a little curl on the tail. Okay, so not just a straight line, because it could look like a addition sign. Or the other thing is capital letters. Capital letters should be avoided because as we remember from our measurement unit, if we have a capital A, that actually symbolizes area. If we have a capital V, that symbolizes volume. If we have a capital, let's see, what else? P, that would symbolize perimeter, okay? So we typically stay away from capital letters and we just use lowercase, okay? So the most common that you're going to see are X. I try to do this as like a cursive, or Y. Okay, but you can use any ones. I like to actually also use I, and I like to like a lowercase I, and then also I like to use a lowercase n. Those are gonna be common ones that we're going to be using. Okay, now next thing is we need to first of all figure out, okay, well, what is an equation versus what is an expression? Okay, so we're just going to be talking about these two different things because sometimes there's like questions that pop up that sort of expect that you know the difference between these two terms. So first of all, an expression is something that has a variable, okay? So basically it's the same as the pattern rule, but using mathematical terms. Does not have an equal sign. So this could be an example. It could be like 5i plus 2. So we know if we see, this is sort of review from before, but if we see a number next to a letter, there's an imaginary multiplication sign there. It's kind of just like a cheat. Remember how mathematicians are lazy? They don't want to actually take the time to write out multiply. So if you see a number and a letter, it's magic sign for multiply. Okay, that's kind of important to keep in mind. So that's an expression, basically like this, okay? It does not have an equal sign. And then the opposite is an equation. An equation does have an equal sign. That's what you are used to working with. So an equation, this would be an example of an equation with a variable. So 3 times something equals 12. Well, what would that be? 3 times our variable, in this case, would be 4. Okay, hopefully that kind of makes sense. So expression, no equal sign. Equation, like equals, right? Equation equal, the root word of equation is equal, so it would have an equal sign. That's how I remember it. Okay, now what we're going to be doing today is coming up with expressions using our pattern rule. Okay, so to change a pattern rule into an expression, this is what we do. Okay. This page is going, just write this down. We're going to go through an example after, okay? It's going to make more sense after we go through it. So these basically are the steps. You write down the operations and the values only. So for example, if it was like times 5 minus 10, right? Like even from our morning math, times 5 minus 10, okay? We know how to do that. We've done all this before. So you don't have to say start at 1, increase by this each time. You don't have to do the words anymore. It's just only what's in the input-output machine. Okay, then this is the main thing for today. We're going to include a variable which usually is put next to the first machine. Okay, and I'll be showing this to you. Okay, so right, the variable, and this is you'll see this as we start doing more of these. But basically, the variable represents any number from the input column. Okay, we'll go through this. I know that you're probably thinking, what on earth is this right now? But I promise we'll get it. Okay, so here we go. This is an example. So I'd like you to draw this in, please, and make sure that you leave quite a bit of space after the input column, okay, before the output column. Okay, so leave a lot of space because we're going to be printing some stuff in here. Okay, so if you need to pause me and write this down now, you can. Okay. All right, so this would be our example. We would have to first of all figure out, well, what on earth is in this machine? What's going on here? How do we get from the input to the output? Then we're going to figure out what the expression is. Oops. And then that's actually it for today. Okay, so let's go through this. Alrighty. Okay, I'm making my screen nice and big here. Alrighty. Okay. So, okay, let's see. Alrighty. Okay. So, First of all, what is in the machine? That's our first step. This is all the way back to last week, okay? How do we get from here to here? Well, let's see if we can find our sneaky pattern. We know this is going up by 4. Okay, so I think that 4 is going to be one of my values, right? Going up by 4 each time. Okay, so let's try, maybe I'm gonna do, just for practice, I'm going to think that it might be times, oh, this is a cool feature. Maybe it's gonna be 4, okay? Times by 4, so 1 times 4 is, I actually don't want to use that. I want to use something darker, sorry. Okay, 1 times, I think it's going to be 4, and then I get 4, and then I do plus 3. Okay, so maybe that's going to be it. Let's see. That would give us 7. 2 times 4 is 8. 8 plus 3 is 11. Okay, yeah, that's it. That was lucky. That worked right away. Okay, so happy days. We figured this out. Times by 4 plus 3. Okay, that is the first step. Critical. That's why we spent all of last week figuring out this pattern rule stuff. Okay, so that's the machine. Times by 4, and then we're adding 3. Okay, good. Hopefully we're okay so far. Now, this is where it gets a little bit more complicated. Okay, so I'm going to say that my input is going to be, I'm going to call it I. Okay, I'm going to call this I for my input. Okay, I like that. I for input. Okay, so if I have my I, which is my input for this one is 1, my input for this one is 2, my input for this one is 3, my input for this one is 4. Okay, so I plus 4, sorry, I times 4 plus 3 equals 7, right? I, which in this case is 1. 1 times 4 is 4 plus 3 is 7. Okay, if my I here is 2, 2 times 4 is 8, right? 2 times 4 is 8, plus 3 is 11. Okay, so hopefully we're okay for this so far. Okay, now if my I here is 3, 3 times 4 is 12, plus 3 is 15. Okay, so hopefully we're okay for this. Now, this is the thing. If I was to continue this pattern rule and say that I had I all the way down here, and maybe my I was, I don't know, 30, for example. If my I, my input was 30, what would my output be? Well, we're just going to continue doing the same thing, right? It's going to be the exact same thing. So we know we're going to use our pattern rule. Times 4, then we're going to do whatever we get plus 3 is going to give us our answer over here. So 30 times 4 is 120. 120 plus 3 is 123. Okay, what if my I was, maybe my I in this case is 100. My input, my variable is 100. Then what do I get as my answer? Same thing. Use that exact same pattern rule. Times 4, and then we add 3. Okay? So 100 times 4 is 400, plus 3 is 403. Okay? So there you go. Now, this is the magical part of today. All that you have to be able to know how to do is write this expression. So it is basically I, okay, I'm just going to use my colors to keep this kind of the same. I times 4 plus 3. That is my expression, okay? That's my expression for this. I've used the variable to represent the input, okay? This is one way I could write it. What if I did it like this? For I. For I, and then I know you guys are getting this, plus 3. Is this the same? Are these two things that I just did the same? They are, right? They're the exact same, because this is what we did from the earlier page. Whenever we have a number next to a variable, there's a sneaky multiplication sign, or it also could be a dot. That means we're multiplying, okay? So that is what you need to do. This is our answer. You have done it. You have figured out an expression that represents a generalization from a number pattern. That is this, okay? So, okay, that wasn't so bad, I hope. It's not the easiest thing, I know. This is the homework, okay? It's in the workbook. It is pages 6 and 7, all of the questions. I would like you to also attempt Stretch Your Thinking A. If you want to do Stretch Your Thinking B, you also can. Okay, let's just look at this. Okay, so here it is, 6 and 7, okay? So, alrighty, they give it to you up here again if you guys kind of want to see. They've used n as the variable in this example. So if you want to see it again, you kind of can. N represents the variable. So in this example, this would be where they put in the n, right? 2, I guess the pattern rule would be times 2 plus 3. So it would be 2 times n, here is the n, plus 3. There you go. That's it. Okay? Or, see how this is the same? 2 times n plus 3 is the same as 2n plus 3. Okay, so this is what you need to do. First of all, complete the table of values, write the expression that relates the input to the output. Okay, you know what? I will do this one. If you get it, amazing. You can go on and you can do this by yourself. If you want to keep watching, then I'm going to do the first one with you, okay? So, first of all, we have to figure out, back to this annoying pen deal. Okay, first of all, we have to figure out what relates the input to the output. Okay, and then we're going to figure out what the expression is. Okay, so let's see here. Okay, my magic number, it's going to be something 5. Maybe it is times 5. Yep, that was quick. It is times by 5. And then I know it is subtract by 2. Okay, subtract by 2. I'm not using my iPad for this, you can tell. Okay, so I'm going to keep going. Okay, so 6 times 5 is 30. 30 minus 2 is 28. Okay. 7 times 5 is 35. Minus 2 is 33. Okay, you can continue with that. Now, the key thing I want to help you with is figuring out this expression. So, all that we're going to do, if we go back to our original page, is this. The variable represents any number from the input column. So usually the variable is next to the first number in the machine. Alrighty. So if I have 5, okay, 5 times, I'm going to say I for input. Okay, input plus, it's minus 2. There we go, minus 2. That is our answer. What on earth? 2. Okay, there you go. Or you could do 5i, which is the same thing, minus 2. Okay, those give the exact same answer. Okay, so this is your answer for the first one. Okay, so key thing is figure out what goes up here, and then you can just attach it to, that's kind of cool, attach it to the pattern rule. Okay, so that's the first question. The next one is this is from our lesson from the other day, so you are turning the figures into the table, And then same deal, continue the pattern, write the pattern rule, write the expression, find, okay, this is a good question. And then, yep, same thing. And then you can do this one if you want to. And if you wanted to, you could write the story problem. So I would like you to do A, but then B is optional. Okay. Alrighty, that is it. Try your best. Okay, we're gonna go over this all tomorrow because I know that it's not the easiest lesson of grade 6. Okay, well done and good luck.